Hello, welcome to STEM Simplified. This is Newton's second law. Motion is constantly happening around us, yet the reasons objects speed up, slow down, or change direction are not always obvious. Physics helps us explain these changes by identifying the forces responsible for motion. One of the most important ideas used to understand this is Newton's second law of motion, which connects force, mass, and acceleration into a single relationship. Newton's second law is summarized by the equation F equals m times a. In this equation, force is measured in newtons and represents the net force applied to an object. Mass is measured in kilograms and describes how much matter the object contains. Acceleration is measured in meters per second squared and describes how quickly an object's velocity changes. This equation can also be rearranged to solve for any variable. Acceleration can be found by dividing force by mass, and mass can be found by dividing force by acceleration. This relationship forms a foundational concept in physics and explains how force, mass, and acceleration are interrelated. And remember this because this is a big topic that you need to know, and I'll also have some practice problems for later. This demonstrates how mass affects acceleration using two shopping carts. When the same force is applied, the empty cart, which has a smaller mass, accelerates more. The loaded cart, with larger mass, accelerates less because it has more mass to push. This happens because mass is a measure of inertia, which we covered in the last week's video, or which is also known as an object's resistance to changes in motion. According to Newton's second law, when force is constant, acceleration is inversely proportional to mass. As mass increases, acceleration decreases. Acceleration is defined as the rate at which velocity changes. This change can happen in three main ways. An object can speed up when acceleration is the same direction as the velocity. Two, it can slow down when acceleration is opposite to velocity. And an object can also change direction, even if its speed stays the same. Mass plays an important role here as well. With the same applied force, a lighter object accelerates more, while a heavier object accelerates less. This reinforces the idea that the same push can produce different acceleration depending on its mass. This part of the video focuses on net force and how net force affects motion. When forces acting on an object are balanced, equal in magnitude and opposite in direction, they cancel out. The net force is zero, so there's no acceleration. The object either remains at rest or continues in its constant velocity. When forces are unbalanced, they do not cancel. This results in a non-zero net force, which eventually causes acceleration. The idea is that net force, found by adding forces as vectors, determines whether an object's motion changes. Now we're going to demonstrate an experiment that helps us understand Newton's second law better. Force equals mass times acceleration. So on my left side here, I have a red cricket ball with a mass of about 160 grams. And on my right side here, I have a white foam ball that has a mass of about 16 grams, so 1/10 of the cricket ball. Now I'm going to apply the same net unbalanced force to both of the objects, and we'll see how their acceleration differs. As you can see here, the white foam ball had a greater acceleration due to its much lower mass. And on the other hand, the red cricket ball had a low acceleration due to its very high mass compared to the foam ball. Here is another visual representation to help you understand Newton's second law further. The empty cart with the smaller mass reaches the finish line in 0.85 seconds, showing greater acceleration. On the other hand, the full cart with a larger mass takes about 2.5 seconds to reach the same point, showing a much smaller acceleration. Because the applied force is the same in both cases, the difference in acceleration is directly caused by the mass. This confirms that when force is constant, increasing mass decreases acceleration and also the other way around, showing their direct cause and effect relationship. Here are some practice problems that you can use to help you understand how rearranging the equation works to find the desired variable. You can pause the video and try these problems now. Let's now walk through these problems to help you understand if you didn't get it on your first try. This slide applies Newton's second law to solve problems. In the first example, force is calculated by multiplying mass and acceleration. As you can see, you are given the mass and acceleration, so you can simply multiply those as follows in the equation F equals ma. In the second example, mass is found by dividing force by acceleration. Again, using the given equation that you have and the variables, you can simply rearrange the equation to find what variable you need. In the third example, acceleration is found by dividing force by the mass. Each problem uses a different scenario, such as a shopping cart, a block, or a rocket, to show you how the same equation applies across various different situations. These examples reinforce how force, mass, and acceleration are mathematically connected. Here's a quick recap just so you know what you should really take away from this lesson. Newton's second law shows us that net force causes acceleration and is described by the equation F net equals m times a, or also known as force equals mass times acceleration. Mass represents resistance to motion, and acceleration always points in the direction of that net force. With this understanding of force and motion, the next step is to explore how objects interact with each other through Newton's third law of motion. Also, the next step is to understand how these principles are applied in real world and engineering and technology. Hope this video is helpful. Please subscribe, like, and share if you can. Thank you.